Display and voice both are clear? Both okay? Display and voice both okay? I will start there. If both are okay, I will start. Both okay. Okay. Start now. See, this is I am taking in YouTube because this is permanent for you. Earlier, how to find strength of bearing type bolts, all discussed. Now, even I have seen so many people, usual bolt strength, shear strength, bearing strength, they happily calculate. When it comes to HSFG bolt, then some problem or confusion. Even IS code has not clearly given some idea, something they left for guessing. Anyway, I can guess it, no problem. Now, so this class is meant for finding design strength of HSFG bolt. Remember, make a note. I will give first steps for you. As I dictate the steps, write the steps. Clear? I will first dictate the steps. Write first steps after the class, not now. After the class, first write steps. Then go for it. Okay, start. I will tell one by one now. Don't see anything here. Do not see anything here. I will write somewhere here. I said see up to where I can write. Space. I think plenty of space is there. That's the advantage of YouTube. Because see, I can go for full board. One nimisha. Further here. Up to here I can write, I think. 1 minute. I just check it because it takes that little lag is there. Yes. Up to there, further this side. Up to here there is no problem. Almost full board. Okay. Advantage. Okay. Now, write correctly step by step procedure for finding design strength of board. Before that, make a note. Before you start all these, make a note here. Note. We already considered design strength for bearing type bolt. See, remember, this class is meant only for HSFG bolt. Some newcomer may ask, what is bearing type bolt? If you don't know, don't come to this class. I am giving idea for HSFG bolt, which so many people find difficulty. So YouTube, and one more thing. Later, any day, you can refer. This will never be deleted. Okay. Bearing type bolt, that is called VDB. VDB is least of V1, VDSB to VDPB. Okay. Design strength, shear strength of bolt and bearing strength of bolt. These are the formula. These are all already over. Among the two, whichever is least. That is the design strength for bearing type bolt. Clear? Design strength for bearing type bolt. Clear or not? First write that way. This is the design strength for bearing type bolt. Okay. Then right here, one more thing. In case of bearing type bolt, remember I told repeatedly earlier classes. So all my explanation of extra is only for the group. Those who are in the steel group. General public, they should understand. See, if you put up two plates here, put a bolt here, this way, tell me, in case of bearing type bolt, the bolt cross section is subjected to what? Bolt cross section is subjected to. In case of bearing type bolts, bolt cross section is subjected to shear. See, it will try to cut the bolt because the bolt is effective in transferring the force by virtue of shear strength. Of course, when shear comes, automatically bearing will come. Now, remember, HSFG bolt, there is no shear for the bolt. HSFG bolt, there is no shear for the bolt. Bolt cross section will not be subjected to shear. I will tell briefly. In HSFG bolt, what you do is, you take the members to be connected, provide the bolt, then tighten the nuts and fully tighten the nuts. Therefore, see, bolt will pass here. Then tell me, the two plates will get compressed. It will press against each other. Fully it will press. Therefore, bolt will be in tension. The bolt will be in tension. The tension load in the bolt is called F naught. Remember, tension force in the bolt is called F naught. Here, F naught. You write here is F naught, which will come little later. Already came in the last class, but still briefly for everybody. F naught. Now bolt will be in tension. Therefore, the bolt will press the two plates like this. When you press the two plates, see, now if you ask somebody, see earlier, if you put a, for example, if you put a, some bolt, for example, made up of a weak chalk piece, put here, apply the force, it will get cut. That is bearing type bolt. But now, not bolt is there, but bolt will not get sheared. It will press the plate. When you press the plate, if someone tries to pull it out, it will not separate because of what? Tell me. Because of what? You see, by the hand, you press this way, tell somebody in the house, but kids, not your strength. Somebody who is weak, pull the plate. You press this way. He will tell, not possible, leave your hand. It will resist by what? Tell me. It will resist. The force, the plate will not get separated because of what? Because of friction. That's why it is called high strength friction grip bolt. HSFG bolt. You write HSFG means high strength friction grip bolt. Here we have to use bolts of higher grade because a part of the F knot will be the what? Which will prevent the sliding. Or bolts should be, that's why usually, see earlier, popular in India, we are using grade of bolt of grade 4.6. FUB equal to 400. But here we are using 8.8 minimum, usually. For 8.8 grade, I already told you earlier, FUB equal to 800. Yes or no? Remember, for 8.8 grade, FUB equal to 800. Remember it? Tell me, you should make a note. Yes. Okay. Therefore, high strength bolts are used. Now, IS code, see now, remember, just to understand, those who want to understand, the force acting this way, perpendicular to plate, is F naught. This is the tension force in the bolt. Tension force in bolt, which will what? Press the plate. Which will press the plate. Press the plate this way. Press the plate and plates will not be, plates will be prevented from slipping because of friction. Okay. Because of friction. These all I told you yesterday, yes or no? Derivation is done, explanation is done, equations are given. These all told yesterday. Someone, newcomer will tell, we are not yesterday. No, for you, only procedure, how to find design strength. Inner theory will come in the regular class. That is not in YouTube. So once in a while, I upload in YouTube. Something important for general public. You learn it yourself only. So now, see there. F naught is the normal force. People who study engineering mechanics knows that F naught into coefficient of friction mu will be the frictional force. Will be the frictional force. The frictional force is responsible to prevent the slipping. Friction, actually here, not mu, they call mu F. Why? Friction. Okay. Frictional force is equal to coefficient of friction into that tension in the bolt, that or whatever force is perpendicular to that plate plane. Okay. Now, this is the frictional force. But into is there. Into what? Friction may not come in one plane. It may come in multiple planes. Sometime, see, if you have this way, friction comes only one place. Suppose I put a plate here, one below, one above. See, one below, one above. If one member is there, one plate here, one plate here, then friction comes here and also here. So, into number of planes offering friction, that is NE, into NE. This will give total force. But one correction, if the bolts are perfectly placed, no question of what? The slots. If the plate bolt hole is like this and bolt is correctly this way, it is the ideal case, then there is no reduction. But if in case in case of some slot is there, overside slot, this way, see, that is more space is there, then this is not good. Here, the slot force is in the direction of the smaller side. They want to reduce the strength by 15%. That is a correction factor of 0.85. But in case long slotted holes, tell me, good or bad? Good or bad? Long slotted, good or bad? In the direction of force, long slotted, good or bad? Bad. So then IS code told reduce the strength by 30%. So they multiplied by a reduction factor called KH. KH. So F naught into mu F into NE into KH is what one force bolt can give frictional resistance. That is the strength of the bolt. Now, a bolt should not get a force more than that value. This is the maximum force that can be developed by friction due to one bolt. If any bolt gets more force, it will slip then. So, see here, VDSF, symbol is C. For bearing type bolt, VDSB, VDB, least of VDSB, VDPB. For friction bolt, new name, VDSF. It is VDSF equal to interchange. See, I told F naught, KH, NE, mu F. I wrote in the way IS code has given. IS code told what? First they told mu F, then after mu F, NE, then KH, then F naught. But remember, this is the nominal strength. For safety, you should divide it by what? Gamma ml. For safety, you should divide it by gamma ml. What is gamma mf? Gamma mf is partial safety factor for safety. Tell me gamma mf. Very important. IS code very clearly told. I will tell you what is gamma mf. See, what is gamma mb? Tell me. What is gamma mb for bearing type bolts? Gamma mb for bearing type bolt. Gamma mb for bearing type bolt. Gamma mb for bearing type bolt. It's but difficulty. After so many questions are over, for bearing type bolt, gamma mb. How much? Gamma mb for bearing type bolt. After so many questions, any problem for voice? I think no problem, I think. 1.25. But here, gamma mb, I will tell little later. Wait for 1 minute. Okay. So, if I don't use gamma mb, nominal strength by gamma mb. And remember, here also IS code told reduction factor to be applied. If number of bolts in the line of the force is beyond a limit, then force will not be equally transferred. So it becomes weaker. So into beta Lj, if applicable, beta Lj, we already know. Everybody who came to this class, if you want to understand this one, you should study the bearing type bolt and understand beta Lj. Okay, then remember, there it is not only beta Lj. There are 3 betas are there. Beta Lj for long joint, beta what? Then beta Lj for long joint, beta Lg for grip length, beta Pk for packing plate. But here, grip length is not considered because it is plates are pressed. Length of bolt will not be counted. Clear? Length of bolt will not be counted. Clear or not? Here grip length is not counted because by any length of bolt it has no effect. There if length of bolt is more, there is chance of bending of the bolt. And packing plate, if it is there, no problem here. So IS code told one thing. See there, page number 76, they told the provision of the long joint as per 10.3.1 shall apply for friction grip bolts also. So friction grip bolts, only one correction. Which one? Long joint effect. So they told, see earlier 3 betas. Now they told only 1 beta. Beta Lg, they told the provision of long joint should be applied if it is applicable. Okay, now 1 minute. There is some problem. See now, I will read IS code. IS code told something. Where slip between the bolted plates cannot be tolerated at working load. Means when you use, you should write everything after the class. When you first you write all the statement. I will tell you statement. See, at working load means not factored load. They do not want slip. Means they permit slip at what load? Tell me. You can do one thing. Under normal cases, working load conditions, they do not want slip. But they told, okay, slip is allowed at what load? Slip is allowed at what load? See, allowed at what load? Working load, actual service condition, they do not want slip. But slip is allowed at what load? Fast. Slip is allowed at what load? Fast. Working load, slip is not allowed means working load. Slip is not allowed in working load. If working load slip is allowed, this bolt is useless. No. Slip is not allowed in working load. Where slip is allowed then? Tell me. Then where slip is allowed? Working load not allowed. Where allowed? Working load not allowed means where allowed? It's too difficult here. What is this? Factored load. Instead of using factored load, they are using other language. What? Tell me. See, we call factored load. They are using one more word. What? Instead of factored load, they use one more word. Can you tell the word? See the IS code. Or you tell me now. Instead of factored load, here they use one more other name. I won't tell you once again. Instead of factored load, they use one more name. You never heard of that one. Instead of factored load, we usually call another name. You are wasting time. Not factored load, another name. People you call that also. Not proof load. Ultimate load. You are going somewhere else. I don't know where you are going. Ultimate load. Clear? Proof load Allah. Where is proof load for a structure? Ultimate load. So, ultimate load or factored load, both are same. Clear? Ultimate load. Now, now remember now, this I will remove now. Why? It's already over. I told the background for you. So, already over. This is actually not required. It is already over. I told only for the reason because in YouTube, steel part I am doing first time. Okay, now, there are 2 cases are there. 2 cases. Case 1 or on 2 cases. See, I do one thing now. See, one of the case. I want to put number 1. See, cases, 2 cases. One of them is slip not allowed at working load. Working load not allowed. See, one thing. If slip is allowed at working load, then it is the bolt is useless. Working load, but allowed in what? allowed at ultimate load. Ultimate load. So other case is slip is not at all allowed. Not at all allowed. Means neither at working load or at ultimate load. First of all, neither at working load or at ultimate load. Tell which is better. They want slip not to, it should never slip, they will tell. Working load also should not slip, ultimate load also should not slip. Tell which is better one. First or second one? First or second, which is better? One case is service load or working load, slip not allowed. But they told ultimate load, in case it reaches ultimate load, slip allowed. But second case they told, slip is not at all allowed, neither at working load nor at ultimate load. Tell me, first better or second better? From confidence point of view, second is better. Okay, so I will do one thing now. I do one thing now. Second case is good one. Now, see, first case, you make a note. Suppose slip is working load, slip is not allowed. But ultimate load, slip is allowed. Someone will tell, sir, if it slips, where is the correction? No problem. Tell why. In case friction force is not sufficient and if it slips, no problem. Tell why. Tell me, no problem. Why? The moment plate slips, what will happen? In case the plate slip, what will happen? Tell me. Nothing to worry. But not good. Nothing to worry. Why? In case the plate slips, what will happen? Tell me. Suppose friction force is not sufficient. Plate slips. Connection will not fail. Tell why. Tell the reason. If it slips, tell the reason. Why nothing to worry? Of course, joint become little weaker, no doubt. Why nothing to worry? This I told you. In case it slips, why nothing to worry? We are managing friction only is the criteria for transferring the load. Suppose friction fails, then nothing to worry. Then the bolt will tell, earlier I was friction type height and friction bolt. I am pressing the plate. Because of that, I am preventing slipping. Now I will do one thing. If the plate is slipping, I will prevent it by my shear capacity and bearing capacity. Or the bolt, if the plate slips, the bolts will suddenly change over to what type of bolts? The bolt will change over to what type of bolts? It will change over to what type of bolts? Once the slip takes place, the bolts will change over to, it will change. Now I am not friction grip bolt, I am what bolt now? It will tell, I am not friction grip bolt now, I am what bolt? Bolt will change over to, if not bearing type bolt. If this road is blocked, I will go by that road. Crossroads are there. Okay, now, but one thing remember, it will behave like a bearing type bolt. But even then, because of the pressing, if the plate slips also, some friction is there, yes or no? Some friction is still there, yes or no? Because of pressing will be there. Some friction is still there, yes. But IS code told don't consider, safe or unsafe? Tell me. Actually, even then also, some friction will be there. Full friction will not be there. Some friction will be there. IS code told don't consider it. You consider only bearing type bolt, safer side. That is, it will have extra strength. Okay, now, see. This gamma MF is, be careful, it is 1.1. If what? Tell me. If, you should write. If the gamma MF is, CIS code there. CIS code. CIS code and see there. It is given. Gamma MF is 1.1 if slip resistance is designed at what load? Gamma MF we should take 1.1 if slipping is prevented at what load? If slipping is prevented at what load? If slipping prevented only at what load? First, gamma MF is 1.1 if you should write slip is to be prevented at service load only, means ultimate load it can slip. But at ultimate load also it should not slip. Then gamma MF is not 1.1. Tell how much? Then gamma MF is not 1.1. If the slip is not allowed at factor load also, gamma MF equal to old one, 1.25. Over. That's all. Now do one thing. Write the procedure. You correctly write procedure. After that, you solve the problem. Clear? Write the procedure. Write the procedure. After that, problem. From tomorrow onwards in the regular class, not here, not in YouTube, remaining problem I will do in the Zoom only. There, I will not explain. I will give the problem and walk out. I will tell, find the bolt strength. Agreed? From tomorrow, when the HSFT bolt comes, I will silently go for a break. And I will tell you get the values and type the values in the class. In the Zoom class, I will tell that way. You continue and tell me the answer. Agreed? That's why steps are required. You are not agreeing. If you agree, I will go further. I will dictate the steps for you now, so that no confusion tomorrow. Okay, start. First, these are not required for us. Now later, connection will be given or known. Sorry. Diameter of bolt is known and grade of bolt is known. Diameter of bolt is known, grade of bolt is known. Sorry. This question I am giving. Sorry. Find question. I write here. Question I will write. I will dictate the question. I will dictate the question. See, I will dictate now. A lap joint is made by overlapping a plate of 16 mm over another plate of 20 mm thickness. Pure imagination. Now, 16 mm thick plate over 20 mm thick plate. Then, total number, there are 15 bolts of M16 grade, M16 of grade 8.8. M16 of grade 8.8. How 16 bolts are given? The width of the plates is 240. It is not required for us. Then, how 15 bolts? In the direction of the force, there are 3 lines. Bolts are in 3 lines along the force. Each line along the force, how many bolts? Tell me. That is what you require. This each line, how many bolts? Along the force, along the line of action of the force, there are 5 bolts in each line. There are 3 lines, each line 5 bolts. So when I cut here, I can see sketch like this. Pitch of 80 mm, end it. See, this is your pitch. This is your end distance E0. Remember, I won't explain again and again. People are knowing it. Those who are regular, they know it. Those who are newcomer, learn it. My purpose is to explain only this confusion of what? Slip, etc. Okay. 5 bolts in each line with pitch of 80 mm, all millimeter, and end distance of all dimensions, if not given, are millimeter. Over. Now, this sketch is not required. Tell clear? You first write the sketch plan and section. Over. Now, this is not required. Why? We want only 1 bolt. Okay, start. This is the question. Now, find design strength of the bolt. Question. Notice. Find, I am dictating now. Design strength of the bolt. Sorry, one thing forgotten. Bolts are high strength friction with bolt. Find design strength of bolt. Design strength of bolts. Bolt, only 1 bolt. For 2 cases. For 2 cases. Two separate, that is two separate questions. Two separate questions. One, case one. You find the design strength, case one. Case one is no slip at service load. Service load only. That is in the bracket what? Sorry. First of all, I am changing now. Case one is no slip. No slip even at ultimate load. Ultimate load. Tell me. Common sense will tell me in the bracket. Common sense will tell. Common sense will tell that no slip even at ultimate load means what? That is no slip even at what load? This is a height of common sense, height of foolishness to give. No slip even at ultimate load means, tell me, understood. No slip even at what? This is somebody will be laughing now. If someone is a person who knows subject, he will be laughing at me. Ultimate load only is called factored load. What you are doing? They are using the word. What is this? Again, I am not telling ultimate load other name. No slip. No slip even at ultimate load. So common sense will tell that is no slip. Even. No slip. But even at what load? No slip at ultimate load means no slip at. Again you are telling factored load. Ultimate load only is called factored load. Why are you getting confused? They told case one, slip not, either you tell no slip or slip not, you can write, either write no slip or slip not allowed, even at ultimate load. That means, common sense question, ultimate load slip is not allowed means what? That is 100%, slip is also not allowed at what load? Ultimate load is factored load. I am not telling that. I am not asking you what ultimate load is called. Such a complication. Sorry. I should stop the class now. If it is not answered, I should stop the class and leave. They told no slip even at ultimate load. Means what? So 100% sure, common sense. Slip not allowed at what load? What is this? Such a simple question you are not answering. Ultimate load. No slip. You should not get tired till the end of the journey. Means halfway through also no. See, they told you start here without strain or with happily drive up to the final point. In between a station is there. So even up to there also no strain. If you don't answer, I won't continue the class. Sorry. If you don't answer the question, I should not continue the class. No slip even at ultimate load means common sense. What? How many times I have to ask it? Sorry, I will take rest and wait for your answer. If you don't give the answer, I will not continue. Ah, yes, finally came. No slip at ultimate load means common sense at service load also. See, for example, from Bangalore you are going to Mysore. Mysore is the ultimate point. In between Mandya. Mandya is a intermediate stage. They told go non-stop from Bangalore to Mysore. Means you should not stop at Mandya also. Yes or no? Or from driving from Bangalore to Mysore, no problem, no traffic problem. Means Bangalore to Mandya also no traffic problem. Clear? From Bangalore to Mysore, if there is no traffic problem, means from Bangalore to Mandya also no traffic problem. Or up to the, see, you can tell somebody, he was a healthy person. Till his, what, final days, till he reached 90s, no problem for him. He did not have any medical problem. Means up to 60, Understood. Till 90 years, ultimate, 90 or 100 years, if he is fully fit, means he is also fit till the 60 years. Second case is not that way. He is fit up to 60 years. After 60, trouble starts. Or Bangalore to Mandya, no traffic problem. Mandya to Mysore, traffic problem. Clear? Second case is what? Reverse. Bangalore to Mandya, no traffic. First case is what? Bangalore to Mysore, no traffic problem. Full free. No traffic jam, nothing. That is, no slip at ultimate load means no slip at service load also. Okay, done. Procedure. Right, note. Write a note here. Case 1. Case 2 I will give later. Case 2, all do one thing. You copy the question. Don't write case 1, case 2. You write question only, question 1. You write question 1, no slip even at ultimate load. Fully clear? No slip even at ultimate load. You write first. Okay, start. Make a note. No slip even at ultimate load means even factored load or failure load also, slip is not there. Therefore, here, bearing type bolt. Here, these bolts, changing over, bearing type bolts, is there or not there? Is there or not there? I told these bolts, first it will behave like friction bolt, later it will change over to bearing type bolt. Is that case is there? Tell me. Here, is that these bolts will change over to bearing type bolt? What? No slip even at factored load. At ultimate load also no slip. So, is there that via media case, up to working load no slip, but after working load slip will take place, bearing type? No. Therefore, in this question, we need not bother about what? About bearing type bolt. Here, we need not bother about bearing type bolt. Clear or not? Because bearing type bolt action will come if slip takes place. There is no slip. Okay, start. Then, theory, right here. Procedure. Slip resistance is required at ultimate load. Clear now? Slip resistance is required at ultimate load. Clear or not? Heading. This is the case of slip resistance required at ultimate load. First, clear or not? Tell me clear, I will go further. Clear. Okay. Right. In that case, design strength of bolt, HSFD bolt, that is, the space problem is there, that is called VDSF. Why this space is left, I will tell you later. So, for second type, I want space. Right now, no space, right here. Design strength of HSFD bolt, that is VDSF equal to mu F Ne KH F naught by gamma mf, right? 1 by 1 into beta Lj if applicable. Start. Mu F is coefficient of friction or slip factor. It is given in table 20. In the question, I forgot one. In the question given sand blasted surface. In the question given sand blasted surface. This is very popular. Between the, not sand actually, it is roughened. See, to develop friction, surface is made rough by sand blasting. See IS code, table 20, for sand blasted surface, tell what is mu F. You should write that way, procedure sheet. Get mu F from table 20. Tell the answer. You should write, get mu F from table 20. Tell the answer. See table 20. For sand blasted surface, what is mu F equal to? That is for the problem. See the IS code, table 20. I think next page is there. Table 20, next page is there. For sand blasted surface, what is mu f? What you are doing? You are not seeing IS code and not telling the answer. See IS code and tell me sand blasted surface mu f. If this way you delay means class cannot be taken. We should type the answer within no time. See IS code. Table number 20. Next page. Sand blasted. Last but one. 0.48. 0.48. But in the procedure you write, mu f is to be taken by what IS code table 20 depending upon what type of roughness they give. So many are there. Okay, then NE is the number of effective interfaces offering friction resistance. Again, one note. If it is single shear case, if it is a case of single shear, NE equal to 1. Procedure. If it is double shear case, NE equal to 2. Don't write numerically here. Then KH is what? A reduction factor for over-slotted. For usual case, KH equal to 1. For short slotted, KH equal to 0.85. For long slotted in the direction of force, KH equal to 0.7. Write everything. Then F0 is the proof load. F0 equal to, this all given in IS code. A and B into F0. A and B is net cross-sectional area of the bolt at threads. That is pi by 4 d square into 0.78. D is the diameter of the bolt. Then F0 is the proof stress. That is taken as 0.7 times FUB. Okay. Write that way. Gamma MF equal to 1.25 when slip resistance is required at ultimate load. And right there, first, because we are right, when ultimate load slip is prevented, gamma MF equal to 1.25. Now write, given M16 bolt, grade 8.8, diameter of bolt is 16, FUB equal to 800. So F0 equal to 0.7 into 800 is 560 MPa. Therefore, and net area through thread equal to pi by 4 of diameter square into 0.78. This you know it. Pi by 4 of 16 square into 0.78. If I ask you, you will give after 1 hour. I will calculate. If I ask you, you may give after 1 hour. Pi by 4 of 16 square into 0.78. 156.83 mm square. 156.83 mm square is what? A and B. Substituting, first you get the value of F0. F0 equal to, where is formula? A and B into F0. A and B. 156.83 into F0 is 560. It will give in 10 to the power 3 Newton. 156.83 into 560 will give you 87.824 10 to the power 3 Newton. This is the proof load. Okay, now next step. Right, next step. After that one, this all I am removing now. Find decisive strength, all I am removing. After that you write. After that. Okay, now F0 is clear. Mu F is clear. NE is clear. KH is clear. Gamma F clear. 1.25. So with that data, right there. Gamma MF equal, I think I written here. If you calculate 1.25, where I wrote? I did not write. I write here now. Gamma MF equal to 1.25 when what? When slip resistance is required at ultimate load. At ultimate load, it is 1.25. Substituting your VDSF equal to mu F 0.48 into NE 1. Why? Single shear into KH, that also 1. F naught, it is 87.824 10 to the power 3 divided by 1.25. Tell the answer. This will give you design strength of bolt. Sorry. Oh, forgotten. Still incomplete. Still incomplete. Okay, now. Lastly, beta Lj. How much? Okay, start. For that, you calculate length of joint. Length of joint is first bolt to last bolt in the direction of force is Lj. Tell Lj equal to 80, 80, 80, 80. 80 into 4 equal to 320 millimeter. Then calculate Lj by D. 320 by 16 is 20. This is more than 15. Therefore, tell me, beta Lj is applicable or not applicable? For general public, I am not explaining. It is already over 1,000 times in the class. You should know that one. You tell, suppose somebody will tell, sir, I don't know. If you don't know me, study it. I am telling only friction grip bolt, not full steel here. Tell me, beta Lj, applicable or not applicable? Beta Lj, applicable or applicable? Answer, big answer. It is applicable. Applicable. Then be as per IS code, beta Lj equal to, you substitute and tell me the answer. Sorry, in this class, I cannot waste time explaining beta Lj. It is already, you are supposed to know it already. Or today only go back, study beta Lj. Answer. Don't give wrong answer. Don't give wrong answer. Because it is a YouTube class. I do not want wrong answer. Beta Lj. Is it point? No, you told 0.975. Wrong. You are making mistake unnecessarily. 1.075 minus 0.005 into ratio is to 20. Oh, correct. Thank you. Congratulations. Beta Lj is 0.975. See, someone who is not knowing, he may ask, sir, how to get it? Sorry. This class is meant only for high strength friction grip bolt theory. These other things you should know. Okay. Beta is applicable. So substituting what? Substituting your VDSF. VDSF equal to mu F 0.48 into NE 1 into KH 1 into proof load. Where is proof load? 87.824. 824 10 to the power 3 divided by 1.25 into reduction factor applicable 0.975. If it is not applicable, you take 1. Give the answer in 10 to the power 3 Newton. Fast. Answer. Answer fast in 10 to the power 3 Newton. Bega. 10 to the power 3 Newton. Give the answer. 32.881 Newton. 881 Newton. That is 32.881 kilonewton. This is the answer for strength of the friction grip bolt if slip resistance is required at ultimate load also means ultimate load required means service load also required, or throughout the life, even at failure also, that is even when the loads are increased by 50%, even at the ultimate load also, slip should not take place. This is the answer. Fully clear? Bega. Fully clear? If fully clear, I will go to second question. If it is fully clear, I will go to second question. Clear? Okay. Now, write question number 2. Question number 2. Write once again. 2 plates of thickness Once again, same question. 16 mm and 20 mm are overlapped and a lap joint is provided. Width of plate is 240, not required. And it is connected using total 15 bolts in 3 lines of 5 bolts each in the direction of the force. So when you consider 5 bolts are coming, these 5 bolts you require only for length of joint. Oh. Now, find question. Question is question is what? Question is, I write here, use M16 bolts of grade 8.8. Then, question, find design strength of bolt if slip resistance is required, only at service load. Clear? That means what? Tell me. You should write one thing. Slip resistance is required only at service load means what? That is slip allowed at what load? They want slip resistance required only at service load. Bangalore to Mandya, no traffic problem. Then traffic problem will come. So slip resistance is required only at service load means slip is allowed at what load? Slip is allowed service load. I am going. If I go outside, I want to come back for 1 month then. Slip resistance is required service load means then slip allowed at service load. What is this? Slip resistance is required only at service load means slip is allowed at ultimate load. Fully clear? Fully clear or not? Question. Fully clear? Second question. Slip resistance required only at service load, but slip is allowed at ultimate load. Fully clear? So now, right. Answer. Given slip resistance is required only at service load. That is slip allowed at ultimate load. Then design strength of HSFG bolt is, tell me, one strength is by friction. Now tell me, you should write here, in that case, at ultimate load, the friction grip bolt will change over to what load? What bolt? You should write it. You should write the statement. Friction grip bolt will change over to what type of bolt? At ultimate load. Friction grip bolt will change over to smooth radial bearing type bolt. Therefore, now the strength is what? Either VDSM, that is what? Friction grip. That is friction grip. Or VDB. VDB means what? Design strength of bearing type bolt. Among the two, whichever is what? Tell me, common sense. Then either the friction strength or bearing type strength, among the two, common sense, whichever is. Answer. Whichever is least. Very easy to understand. Then we should take what? You should consider the service load, you consider friction, but ultimate load consider bearing. So design strength will be either strength based on frictional resistance or strength based on bearing type bolt. Among the two, whichever is least. Fully clear? Pass. Fully clear? Full clear or not? Full clear? Whichever is least. Okay. Then, right here. VDSF is same formula. But gamma MF is, tell how much? Now gamma MF. Gamma MF equal to not 1.1. How much gamma MF? Tell me. Now gamma MF is not 1. Gamma MF equal to 1.1 when slip resistance is required at only service load. Service load. So therefore, this 1.25 will become 1.1. Okay. Beta Lj is there. Start. Other things are all same. So write all this parameter once again. Correct? Or you write procedure. Now happily find the VDSF value in the same way as last time, but only one change. Instead of 1.25, use what? Tell me. Only one change. Instead of 1.25, use what? Tell me. Answer. Instead of 1.25, use. Instead of 1.25, use how much? See IS code. Very clearly given. In the IS code, they are given very clearly. If you want frictional resistance only at service load, then gamma MF is 1.1. Or if you want frictional resistance even at ultimate load, 1.25. Tell me answer. That is same as last time, no change. Instead of 1.25, you should write a note, procedure. Everything is same procedure. Everything is same procedure. Only change is instead of 1.25, use 1.1. Okay, over. Therefore, tell the answer. All this you once again make fair copy. Once again make fair copy. Again make fair copy. Again make fair copy. Everything over. Change it to 1.1. Tell the answer. Change it to 1. You should write once again. Remember, don't be lazy. You solve two questions systematically. Every statement you have tried. So that later, depending on the case, refer either that question or refer this question. Don't write, see last time, see last time. Everything make fair copy. Tell the answer. It is not 156. Sorry, it is correct. This is correct. 156.83. This is correct. This value will change. How much answer? Don't give wrong answer. 45.21. 45.21 10 to the power 3 Newton or what? 45.21 kilonewton. Correct? 45.21 kilonewton. Remember, this is your VDSF value. That is this value. Clear? That is your VDSF value. That is that value. Clear or not? Fast. That is VDSF value. You tell me clear, I am rubbing the full bore. You tell clear, I am rubbing full bore. If you tell clear, I will rub the full bore. Clear. Okay. Now, tell me, VDSF over. You also require VDB. Very sorry, VDB, I will not explain. Tell why? Tell me. VDB, I will not explain. Remember, that answer is, this answer came 45.21 kilonewtons. Okay. Now you require to get VDB. That is design strength for bearing type bolt. Bearing type bolt. Or note, go back to old classes, those who are not in the group, go back to old cases, not old, here for those who are my students, go back to old classes. Those who are not in the group, they came seeing only YouTube for friction bolt, go back to old cases of IS code. And if you don't know it, then why you came to, see, if you don't know how to find bolt strength for ordinary bolt, then why you want to learn for friction with bolt? Then if you do not know how to drive a car, then why you want to drive a truck or bus? If you want to learn to drive a truck or bus, you should at least know how to drive a car. You don't know how to drive, first, as I will tell, first to drive a car, get driving license, then come here, I will update you. Or if you do not know how to drive a luxury car, very posh car, okay, you can learn. But if you do not know how to drive a Maruti 800, they will tell you don't drive this vehicle. You don't go to showroom and a new brand vehicle, Fortuner. You tell, I want a test riding. Okay. Please show your DL. You tell him, no, I don't have DL. I am learning for your vehicle. They will tell, go. I am not giving to you. You first show your DL. Okay. Show the DL. Oh, you have got light motor vehicle. Or if you go by Maruti car there, or any car, ordinary car, they will tell, oh, this person at least knows how basic driving. Okay, now sir, you take the vehicle, don't go to main road, somewhere here go, or he will see how you are driving. If you don't have a DL, they will tell, don't come here. Okay, start. World classes, that's all. That's all. But I will write everything. I will not explain, write everything. Those who are in the group, tell me clear or not. Understood? Those who are in the group, tell me clear or not. Others should know how to do it. Start marking. World classes. VDB is list of either VDSB or VDPB. Okay, start. VDSB, that is design shear strength. Design shear strength equal to FUB into what? By root 3 gamma MB into NN into ANB plus NS into ASB into betas, all applicable now. You should write all applicable beta, that is beta LJ, comma, beta LG and also beta PK, whichever applicable. Whichever is not applicable, tell the answer, don't write it. Whichever not applicable, leave it. Or if you are very eager, tell answer. If something is not applicable, 37.36. Oh, sorry. Okay. ಮತ್ತೆ ನೀವು 40 something ಹೇಳಿದ್ರಿ. What is this? If you do this way, what I can do? ನೋಡಿ, you only told 45.21. This is very bad. YouTube class, I do not want such mistakes. Again, I check everything. Oh, pi by 4 of 16 square. Such a mistake to commit. You are actually wasting my time. 156.828. 40 into 150.828 into 0.48 36.95. It is 36.95 answer. 37. I don't know how to see. This way I am going to leave the class. As it is. I told this is a YouTube class. In YouTube class, the people are there who will comment unnecessary calculation mistake. I do not want such mistakes. What is this? Your FUB equal to 540, correct? 560. FUB is 560. ANB is, you are unnecessarily giving trouble to me for no reason. 156.828. So your F0 will come 156.828 into 560 is 87.823 10 to the power 3. Then your VD another VD symbol VDSF will come 87.823 into 0.48 into 111 into 0.975 divided by 1.1. 37.36. Then why you told her, sorry, see, your VDSF will come 37.36, 10 to the power 3 Newton. Then why you told wrong value earlier? This is called unnecessary troubling me in the class. This is called, so if it is a college class, by this time, I would have walked out of the class. You don't know. If it is a college class, I would have walked out. I would have told sorry, not continuing. Okay, 37.36, change it. Last time. But someone told me earlier, not 37. He told 32.881. Why? He divided by 45.21. Somebody earlier told me 45.21. How you got 45.21? Suresh told 45.21. So that earlier, you are wasting my time. Earlier, 45.21 is now changed over to 37.36. Okay, done. Don't waste time. Okay, now, start. Over. Start now. First, NN equal to 1. A and B equal to pi by 4 of 16 square into 0.78. NS equal to 0. Considering shearing through threads, right there. Threads. Betas. LJ equal to 300 millimeter, 320 millimeter. 320 millimeter. Therefore, LJ by D equal to 320 by 16 equal to 20, which is more than 50. Therefore, beta LJ is applicable. Equal to calculate answer. It answer ready? 0.975, correct? Beta LJ, I don't remember. Is it 0.975? Is beta LJ 0.975? Beta LJ, yes, okay, over. Then LG equal to 20 plus 16 equal to 36. Therefore, LG by D equal to 36 by 16, 100% less than 5. Therefore, beta LG is not applicable. Beta PK anyway is not applicable. Why? Tell me. Beta PK first of all is not applicable because there is no packing plate. With all these details, if I substitute here, your VDSB equal to FUB 800 divided by root 3 divided by gamma MF. It is a gamma MF. Divided by gamma MF is how much? 1.25 into bracket 1 into pi by 4 of 16 square into 0.78 plus 0 into 0.975. Tell the answer in 10 to the power 3 Newton. Big answer. Shear strength. Olden days. I am not explaining. People should know. See, Maruti car, you should know how to drive before you take a test drive of Fortuner car or Rolls Royce. Don't go there telling I don't have DL. No answer. Beta VDSB answer. Don't give wrong answer no. FUB is 800. Answer. .5 kilonewton. Okay. 56.5 kilonewton. Now, we require VDPB. That is a design bearing strength. Bearing strength equal to 2.5 kb into D into T into FU, not FUB. FU for the plate. For the plate. Divided by what? And one thing for what? Take what? FE 410 plate. Forgot to give. Divided by gamma MB. Okay. Start. First, KB is least of 1. Tell the answer. Second one. Tell the answer. Third one. Tell the answer. Fourth one, I will tell one. First one answer. Bega. Sorry. Maruti car driving, I am not teaching here. Maruti car driving, you should know before you drive a Fortuner car. First one. E0 is 40. Diameter of bolt hole is 18 millimeter. Why? 60 mm diameter bolt hole is 18. Answer. First one. Bega. 1.23 yeah. 40 divided by 3 divided by 80. How 1.25? 0.711 it is coming. What? 40 is the egg distance. Divided by 3 divided by 80. 0.741. Allu mistake. 0.741. What is this first of all? Maruti car you are not drive. You are going for Fortuner. Second one. Pitch is 80. Second one. Pitch is 80 divided by 3 divided by 18. Is it 1.231? Second one? Yes. Second one is 1.231. Next one. FUB by FU. Remember, FU for the plate equal to how much? Tell me. For plate, what is FU equal to? Tell me at least FU equal to. For plates in India, you take FU equal to how much? How much FU you take the plates? High strength is for bolt, not for plate. FU for the plate 410. And tell the answer. Next number. High number will come. 800 by 410. I am telling the answer. Is it 1.951? Next number. Is it 1.951? Fast. Next number. Is it 1.951? You should agree fast. Next number. Is it 1.951? Why this much difficulty? One FUB by FU, you are taking hours together. Okay. Last number is 1. Therefore, KB equal to least of all the values is 0.741. Then, diameter of bolt is 16. Thickness T. It is either 16 or 20. Either 16 or 20, whichever is least. Therefore, tell T equal to 16 mm. Over. Substituting your VD PB equal to 2.5 into KB. Where is KB? 741 into 16 into once again into D 16. Thickness also 16 into 410 divided by 1.25. This is in Newton. Tell the answer in kilonewton. Tell the answer in kilonewton. Shear strength is 56.5, 10 to the power 3. This one. Answer. Tell me in 10 to the power 3 Newton. Answer. High strength will come. 151.56. Over. Now, last step. So, we already found based on friction, answer is 33.36 kilonewton. When it changes to bearing type bolt, VDSB is 56.5, VDPB is 151. Therefore, single answer. Therefore, VDB, design strength, VDB, that is design strength for bearing type bolt. Bearing type bolt. What is the answer? What is the answer? Tell the answer here. Answer. Two values are there. Tell one answer. What is the answer? Design strength for bearing type bolt. 151 now. Shear and bearing. Shear you got how much? I forgot. You got shear strength 56.5. Bearing is 151. Allu confusion. They are also wrong. What I can do? If you make such mistakes, I am helpless. I don't know why you are making this mistake. 155. Allu Chaukasi. Someone told 151, someone tells 155. First of all, I don't know why this mistake. You can do in the Zoom, don't do in YouTube. Answer. Therefore, design strength. How much? You are not answering. This is the bearing strength. We already got shear strength. Tell the design strength. 56.5 kilonewton. Okay. Therefore, last answer. Therefore, what? Design strength of bolt. Design strength of HSFG bolt equal to, tell the answer, either your VDSF or your VDB, whichever is least. VDSF came 37.36 kilonewton, VDB came 56.5 kilonewton. Therefore, answer, tell the answer. How much? If the slip is allowed, if the slip is to be prevented only at working load, but if slip is allowed at ultimate load, then the design strength equal to how much? 37.36 kilonewton. 37.36 kilonewton. Over. Jai Hind. Why Jai Hind? Tell me. Why Jai Hind? Why Jai Hind? Why Jai Hind? Why? Over. Nothing is there. So now remember. Later, when a problem comes, what will happen? Condition will be given. Whether slip is to be prevented only at service load, but allowed at working failure load, ultimate load, or even ultimate load, it is prevented. That data will be given. Instead of single shear, it can become double shear. Then what will happen? It will become double shear. Tell me, NE will become how much? Then NE will become, if double shear case, NE will become, answer, in case you get double shear, remember this NE will become, not 1, how much? NE will become, you are not answering. Today you got single shear. If double shear, NE will become 2. That's all. Or instead of sand blasting, if some other roughness is given, see there, it is given there. Surface not treated, that is nothing, 0.2, very weak. Surface blasted with short or grit with any loose rust removed, no painting, 0.5. Surface blasted with short or grit and hot dip galvanized, depending on that one, take mu F. Usually sand blasting 0.48. Okay. They told one thing there. You should not take mu F more than how much? Tell me. See there, IS code made a mistake. They told mu F in the bracket. They told 0.55. It is a mistake. They should have given mu F is not to be taken more than how much? Suppose you provide very rough surface, even then, what? IS code told, if you provide a very rough surface, high friction is there, still IS code wants mu F not more than how much? IS code wants mu F not more than, see their main statement. They made a mistake. They wrote mu F equal to 0.55. It is wrong. They should have given mu F is not more than 0.55. Okay, that's all. Tell me, friction grip bolt, this will not be removed. See, this class will not be deleted. It will be there for any number of days. Therefore, full clear. In future, those who are in the group, if you got difficulty for friction grip bolt, come to YouTube class, refer class number 24, go through it and understand. Tell me, full clear how to find strength of friction grip bolt. Okay, thank you. We will see. Tomorrow, remember, I am changing over to welded connection. I am going to welded connection, and tomorrow class will be once again in the Zoom only, not in the YouTube. Only some critical part I will do in the YouTube. Like when I go to welded connection, maybe eccentric connection I may do in the YouTube. When I go to columns, some standard cases of finding analysis I may do in the YouTube. But all theory, all I will tell in the Zoom only. In the YouTube, only procedure. That too critical examples or beam. When I come to first design of beam, I may do in the YouTube. Subsequent etc. in the class only. Okay, thank you.